All right, lesson 5. Sets, absolute value, and addition and subtraction of signed numbers. This is a set right here. So basically a set of numbers. They just designated this as like set A. It could be any numbers, okay? And it's equal to, and we use these parentheses to designate a set of numbers. 1, 2, 3, 4, 5 happens to be in this set. We talked about this the other day. I don't know that you need to write that down again. Just a reminder that natural numbers are 1, 2, 3, 4, and forever up, right? And then we have integers, which go forever down and forever up. Okay, all the negatives, all the positives, including 0, those are the integers. The one that I skipped is whole numbers. Whole numbers is the same as natural except for what? Zeros in it, okay? Quick question, is this a set, a subset of the natural numbers? Yes, okay? Like it fits inside of that. All right, it doesn't work the other way around though. Are the natural numbers a subset of A? No, because all of them are not in A. So in order to be a subset, they have to all be included in that set. All right. All right, absolute value. So absolute value means the distance away from 0. All right, it's a distance. And when we measure distance, distances are only positive. All right, so if you were to measure your desk with a ruler, you would not get a negative distance. So absolute value means always positive. We're talking about the distance from 0. So the absolute value of 0 is, everyone? It is 0. All right. And let's do the absolute value of -5. So these bars mean absolute value. So like how far away is this number from 0? 5. And you drop the bars, right? So you don't write the bars anymore and you make it positive because absolute value is saying distance from 0. All right, and what's the absolute value of -7.12, everyone? Great. What's the absolute value of +5? Yeah, it's also 5 units away from 0. All right, so when you think distance, always positive, it just stays positive. If it's negative, it goes positive. So this one would just be 7.12. And this last one would be 3/4. All right. So take the bars off, make it positive. That's absolute value. Let's try it with like something in between. All right, I have the absolute value of 11 minus 2. So first you would need to show me what is 11 minus 2. And we would all be like, that is 9. Show me that step. All right. Then do the absolute value of 9 is 9. And that would be your answer. Okay. All right, on this next one, start with the inside, just like their parentheses. We always do inside the parentheses first. You want to do inside your absolute value bars first. Leave the negative on the outside. So what is 20 minus 2, everyone? It is 18. Now we can drop the bars off. So the absolute value of 18 is 18. What happens to the negative, you guys? Yes, it like stays on there. You guys agree? So this answer is -18. Because the negative is on the outside, the absolute value is not affecting it. Okay, just stays on the outside. All right, this is what the book says, and we're not going to do this. Okay, it says use directed numbers and the number line to add +3 and -5. I find this to be like more confusing than literally just adding them together. Okay, the book is trying to say, hey, let's start at +3. So you're like, all right, here's +3, boop, and then I'm going to go -5, boop, and like count. And you get -2. But I find it, just do not ignore the directions, okay? And all I want you to do is be like, all right, what is +3 plus -5? All right? Now, +3 is just 3, plus a negative is just -5. And then you're like, that's -2. That's the work I would like to see, okay? So don't do the number line. Just ignore those directions. All right, and now we have the opposite. We're going to add -5 and +3. So they switched it, so the 5's negative. Now, remember, you are adding, by the way, the plus just means plus, right? You guys remember in pre-algebra, we taught you, like, who wins the war? So, like, are the positive numbers bigger or the negative numbers bigger? The negatives are bigger. That's how I know I'm going to get a negative answer. If you have opposite signs, you subtract. Okay, so the difference is 2, and the negatives win the war because I have a bigger -5. All right, And you want to practice all these without a calculator. Okay, make sure you can do them. All right, the commutative property of addition. I would write this down. Sometimes they ask this on the test. Like, what property is this? Okay, so we have commutative property. The order in which two real numbers are added does not affect the sum. I don't know if you need to write all of that down or if you just want to show the example. Okay, you could either write the sentence or you could show the example. Basically, all we're saying is that 4 plus 3 is the same as 3 plus 4. So it does not matter the order in which we add. We're going to get the same answer. You can add in any order. Does the commutative property work for subtraction, you guys? No, you cannot do this, right? Those are not the same. You guys agree? This is 1, this one's -1. So subtraction is not commutative. Commutative. All right? It is only of addition. All right, so here's another one where they're going to be like, use directed numbers to add. And they're like, do a number line. I feel like that is way more confusing than just adding. So do not do the number line. All right, let's just add. Okay, so I have -4 plus +2 plus -1 plus +5. There's a lot of extra signs in here. Okay, so how I recommend doing these. Gather the negatives. They're on the same team, okay? So I've got -4 and -1. Those add to make a bigger negative. What do we get for that? So I would like to see this work, all right? And then add your positives. Your positives are also on the same team. So I have 2 plus 5, which is a +7, and you only need one plus sign. All right, who wins the war, the positives or the negatives? Yes, and we subtract the difference there. We get +2. Oh, that's it. Yeah.
So can you just write the signs, like you don't have to write the addition?